Hello everyone and welcome to my channel. So in today's video we are going to solve a decent limit question, which is root cosine x minus root cosine 3x over 1 minus cosine x when x approaches to 0. So for the very first thing that we have to do in limit questions is putting the x, replacement of x. So let's write down what we are going to get. It would be root cosine 0 minus root cosine 3 0 over 1 minus cosine 0. What I did is just replacing the x's at x equal to 0. So cosine 0 is 1, 3 times 0 is 0, and cosine 0 is 1, and cosine 0 is 1 as well. So the answer would be 1 minus 1 over 1 minus 1, which is 0 over 0. So it means that this is not the answer. So we have to actually apply the L'Hopital rule. I told you about the L'Hopital rule before. In limits, whenever you get to 0 over 0, you have to apply the L'Hopital rule. So to apply the L'Hopital rule, we have to find the derivative of the numerator over the derivative of the denominator. This is the L'Hopital rule. You can take a look at the very first limit question that I solved in my videos, in my channel, and you can find out what the L'Hopital rule is exactly saying. So we have to find the derivative of the numerator over the derivative of the denominator, x approaching 0. So again, rules in derivatives. We had several rules. Rule 1 was u plus v prime, or derivative of u plus v equals u prime plus v prime. The other one was cosine u prime equals minus or negative u prime times sine u. The third one is sine u prime equals u prime times cosine u. And the fourth one is cu to the power of n prime equals c times n times u prime times u to the power of n minus 1. There were two other ones as well. U times v prime is u prime times v plus v prime times u. You have to memorize all of these things for all the derivative questions. This is the last one. Okay, so let's go ahead. Let's write down the question once again. X. This is cosine, sorry for my handwriting. So by making use of the first rule, we can simplify the numerator and the denominator. So the u is root cosine x and the v is root cosine 3x. And the denominator, the u is 1 and the v is cosine x. So let's go ahead and apply the first rule. Over 1 prime minus cosine x prime, right? So whenever I get to roots, I change it to the power. If you remember from the previous videos, I always do that. And whenever I get to 1 over a function, I again apply using the powers. So this is the first thing that I always do, and this is the second thing. So right now we have root. So I'm going to rewrite it as cosine to the power of 1 over 2x prime minus cosine to the power of 1 over 2 3x prime, right? Over 1 prime is equal to 0. So 0 minus cosine prime is gonna be based on this formula, so it would be negative u prime or x prime times sine u. So cosine x, the x is the u in here, u prime, negative u prime or negative x prime times sine u times sine x, correct? X prime is equal to 1, right? So let's go ahead. Limit of this guy. I'm going to apply 1 times here and 1 times there. It wouldn't harm actually. And I'm going to use the fourth rule, cu to the power of n prime. So my c is 1 in here, my u is cosine x in here, and my n is 1 over 2, right? So I'm going to apply this rule, c times n times cosine x prime or u prime times cosine x or u to the power of n minus 1, n 1 over 2 minus 1, minus the same thing here. The u is 1, the n is 1 over 2, and the c is 1, the n is 1 over 2, and the u is cosine 3x. So it would be, the derivative would be 1 times, or c times, n times u prime cosine 3x prime times cosine 3x to the power of n minus 1, 1 over 2 minus 1. 1 over 2 minus 1 is equal to negative 1 over 2. So I'm going to write negative 1 over 2 in here. Over 0 minus times minus. So minus times negative would be positive. 1 times sine x. Then let's go ahead. X approaching 0. 1 times 1 over 2 is 1 over 2. Cosine x prime, or the derivative of cosine x based on the formula, is negative sine x times cosine x to the power of 1 over 2 minus 1. So it would be cosine x to the power of negative 1 over 2. 1 over 2 minus 1 is negative 1 over 2. Minus 1 times 1 over 2 is 1 over 2 times cosine 3x. Based on this formula, cosine 3x prime would be equal to negative u prime or 3x prime times sine u or sine 3x. 3x prime is number 3, so it would be negative 3 sine 3x. So here would be negative 3 sine 3x times cosine 3x to the power of negative 1 over 2 over sine x. This part is sine x. So we would have negative 1 over 2 sine x times cosine negative 1 over 2 minus 1 over, let's make it a little bit more simplified. Negative times negative would be positive. 1 over 2 times 3 would be 3 over 2, right? So we would have positive 3 over 2 times sine 3x times cosine 3x to the power of negative 1 over 2 over sine x. So right now, if we take a look at the problem, we are having a sine x in the numerator and a sine 3x in the numerator and a sine x in the denominator. I want to sort of cancel out these sinus and like these sinuses. So what I can do is that I'm just wondering what would be the result for sine 3x over sine x. Why? Because I want to cancel out these two somehow. And I'm pretty sure that these two are not the same because this is x and this is 3x. So I'm just wondering how I can basically apply the, cancel out these two. So I'm going to zoom in to this part of the question and I'm going to see what would be the answer. So the first step is just replacing the x. So let's do it. It would be sine 3 times 0 over sine 0. 3 times 0 is 0, so it would be sine 0, which is 0 over 0. Again, it's not the answer. So whenever, again, we got to the 0 over 0, we have to apply the L'Hopital rule. The L'Hopital rule says derivative of the numerator over the derivative of denominator. Sine 3x prime. We found out or not? No, we didn't find it out. Based on this formula, the sine of 3x, Ru would be 3x, would be 3x prime times cosine 3x, right? Sine u is u prime times cosine u, so sine 3x would be 3x prime times cosine 3x. So it would be 3x prime times cosine 3x over sine x prime is cosine x. Limit x 0. So 3x prime is just 3. So it would be limit of 3 cosine 3x over cosine x, x approaching to 0. So let's replace the 0. 3 times cosine 3 times 0 over cosine 0. 3 times 0 is 0. Cosine 0 is 1. Cosine 0 is 1. So it would be 3 times 1 over 1 or just 3. Right? So the answer for this would be 3. Alright, so now I can cancel out all these sinus in here. How? Let's write this guy in here once again. So it was, or let me just copy like this. It would make my life easier. So I can cancel out these guys. This would be 3, this would be 1, this would be 1, right? So the answer would be limit of negative 1 over 2 times, this would just cancel out, cosine x to the power of negative 1 over 2 plus 3 over 2 times, this would be 3, this would be 1 based on what we found. So times 3 times cosine 3x to the power of negative 1 over 2 over sine x would be cancelled out as well and would be just 1 at x approaching to 0. So it would be limit of negative 1 over 2 cosine negative 1 over 2x plus 3 over 2 times 3, which would be 9 over 2 times cosine 3x to the power of negative 1 over 2. Negative 1 over power of negative 1 over 2 is 1 over x to the power of positive 1 over 2, and it is equal to 1 over root x. This is what we know from before. I'm going to apply it for these guys in here. So limit negative 1 over 2 times 1 over root cosine x based on this guy in here, plus 9 over 2 times 1 over root cosine 3x, again based on this guy in here, x approaching 0. So it would be negative 1 over 2 times 1 over root cosine 0. I'm going to replace the x's, plus 9 over 2 times 1 over root cosine 3 times 0. 3 times 0 is 0. Cosine 0 is 1. Cosine 0 is 1. So the answer would be negative 1 over 2 times 1 over root 1 plus 9 over 2 times 1 over root 1. 1 over root 1 is 1. 1 over root 1 is 1. So negative 1 over 2 plus 9 over 2, or 8 over 2, which equals to 4. That's the final answer. Thank you guys for watching this video, and I would appreciate if you could subscribe to this channel and like this video. Thanks for watching.